Hi, this is Margo. This is Sunday afternoon, October the 18th, 2020. I'd like to welcome everyone to the show today. This will be my weekly update for methane and sea ice that I will put on YouTube. I'm also going to go over Sam Carana's latest blog post that he put out this week, and we're going to look at methane from the NOAA data and from the CAMS data, and then Arctic sea ice as well, and a little bit of Climate Reanalyzer and some earthquakes. So that's what we have lined up for today. I hope everyone is doing as well as possible, and the week was hard for me, but you know, I'm here and we're here watching everything unravel and collapse. I'm a watch person on the wall looking at the collapse of the environment, especially tracking methane and sea ice and other things as well. And I do believe we are in the end times, and so you know, I'm here to keep everyone updated as we watch everything go. If you like the shows, I'd like to suggest that you check out my Subscribestar page. The link is in the description box below, and I do pretty much a daily update for my members over there. And for the last few weeks and months, it's been a daily update. And you know, I might miss a day here or there, but we go over methane and earthquakes and other things, and I share articles and do Bible readings and things. So it's a small community, but I like it, and we're able to communicate over there, and I'm able to receive and send private messages, and I just like the platform. It's a safe place for us to go and be. So let's get started with the NOAA methane data. I know everyone is anxious to see what's going on. So we're looking at the 477/469 millibar reading for yesterday, October the 17th, for the Met-1 satellite. This is the morning reading. The mean or average was 1913 parts per billion, and the high reading was 2336. And the highest range is in this pink color, what you see up here throughout most of the northern hemisphere, and that range is between 2,000 and whatever this top number is in the range on all of these. And in this case, it's between 2,000 and 2336 parts per billion. We're also seeing some pink over the southern hemisphere as well. So the high readings are spreading out somewhat. In the afternoon, the mean was 1909, and the high reading was 2402. On the Met-2 satellite in the morning, the mean was 1890, the high reading was 2338. In the afternoon, the mean was 1891, and the high reading was 2504. So here's the spreadsheet and the chart that we're working off of. I've been tracking methane since March of 2019, this 477 level. So here we are for the data for the 17th, and here are the mean numbers that I called off, added up and divided by 4. And we come up with an average of 1900.75 parts per billion. And so that's showing an increase over last Saturday, of 1.75 parts per billion. So we've hopped back up above this 1900 line, and we could have peaked out. I think we did peak out here at that top. I have it highlighted here. That would have been on September the 25th at 1904.25 parts per billion. It's been going down since then. So that happened in the middle of the week. So so on the 26th it was 1903.5. Then it was just going down. So since the 25th it's been going down. So on the week of the 3rd it went down 1.5. On the week of the 10th it went down 3. And then this week it stair-stepped back up 1.75. So last year it peaked out here on October the 12th at 1885.75, and last year after that it was going down. It went down 3 weeks in a row, and there were significant decreases, a -1, a -2.5, a -3.5, and then the week of the 9th it went up 0.75, and then I missed a weekend there, but there was a 10-day period here from the 9th to the 19th where it went down 7.5, and I've been consistent every week, I think, since then. So that's what we've got. And then the lowest we reached was December the 28th of 2019 of 1861.75, and then it started going back up in January. And so the change for this year since March the 1st has been an increase of 24.25 parts per billion, and since March the 1st of 2019 it's been an increase of 43.5 parts per billion. So here's what it did daily, every day this last week. So here was Saturday the 10th at 1899, and then on Sunday it went up 1.5. On Monday it went up another 1.5. On Tuesday it went up 1 part per billion. So by the 13th we had already seen an increase of 4 parts per billion. It was back up to 1903. So I was thinking we might be heading back up to a new peak. And then on the 14th it went down 1. On the 15th it went down 2.75. On the 16th it went up 1.25, and then the 17th 0.25. So we've ended up 1.75 higher than last Saturday. So I will keep bringing this data to you on a weekly basis. I think it's important to watch this, especially since we're really in uncharted territory, and you know, we just don't know what's going to happen. We've never seen it this high in recorded human history, where they've been able to record the data. Of course, it's been higher than this when they've had mass extinction events and volcanoes and things, but you know, that's where we're headed really fast. So now we'll go over the CAMS data. We're looking at Copernicus Atmosphere Monitoring Services. They're out of the EU. And I have methane pulled up. I have the Saturday data loaded up, Arctic view, and surface level. So here's the color ledger at the bottom. So here's where it left off on Friday. We're seeing it pop off on Iceland. Here we're seeing this problem area in the North Atlantic just off this Canadian coastline. This is bubbling back up. Now we saw a decrease in activity at around Severnaya Zemlya, and we had seen some blue come in, which was a lower methane reading. We had seen it down to like this blue, 1900, and this is parts per billion that had been coming across, but now it's filled back up with green. So this dark green is 1920, and then it goes up. As we go to the right, it goes higher in the readings. And this, like this yellow green, is 2020. The bright red is 2100. And the dark brown, brownish red is a range between 10,000 or 2160 and 10,000 parts per billion. So let's run this. Now we had been seeing a lot of release here in the Scandinavian area, and it was pushing out high readings across the Barents Sea and the Kara Sea, and that's calmed down significantly. We're still seeing some a little bit popping up, and then in the forecast period it's rushes coming back to life. So the data is for Saturday, and the forecast runs Sunday through Wednesday. We're starting to see a tiny bit of blue just wafted around from Greenland. See, Greenland starts out in the blue and then it goes into the green in the forecast period. So it doesn't stay blue for long. When we look at Climate Reanalyzer, you're going to see an area from this Chukchi Sea over to the Beaufort Sea. This, like this area here, that's very high in 2-meter temperature anomaly, and we've got it's been set up there for weeks, and so we've had like really high readings up here, and the Arctic has been up to, I think the highest I saw it this week was 5 C or 4.9 to 5 C higher than normal. This is the air readings, air temperatures. So we're not seeing as many reds and yellows and oranges, so it is a decrease, but these are still very high readings. You have to remember that just because it's a decrease it's from the highest, and we saw an increase this week, so we're not done with methane. and we won't be done. This is the most potent greenhouse gas. Gives you the bang for the buck, so to speak. The most bang for the buck. So here's the North Pole view. So we're seeing Europe fill back up. It's coming back to life with quite high readings. The UK, and here's the Persian Gulf, here's India, here's China. It's still spilling out over the coastline here in India and here in the Bengal Bay, and next to China it's in the green zone spilling out. And in the forecast period we have higher readings also spilling out across the coastline. On the interior we're seeing some lower readings. It's not just totally filled up with the dark brown. Here in North America we're still seeing high readings on this eastern seaboard of the US. Still seeing high readings here in Canada, just south of the Hudson Bay, and high readings in California with the fires that are still burning, and then high readings spotted around throughout the US. We're seeing higher readings also in the usual spots in Mexico and here in South America. It depends on the climate and the temperature and the population, you know, how densely populated a place is and things like that. What kind of industry is there? Agriculture. Okay, here's the global view. We're still seeing it come up along the coastline here in the Antarctic. I've also started reporting on things in the Antarctic in my daily shows. I will start showing more of the Antarctic as the Arctic kind of slows down, but right now I'm still focused on the Arctic and watching the sea ice. We're in big trouble with that sea ice. Looks like New Zealand has some higher readings this week, and that the Northern Island, see, there it is popping up right there. Here's the 500 HPA level. I'll refresh so we can get the correct color ledger. They need to fix that. I don't know why they don't fix that. The highest readings we're still seeing here over China and India. We see some higher readings spread out across the Arctic regions in Russia. We're starting to see some blues pop back up. It's not just all green now. So this is showing lower levels of methane. Here's total column. This is where they add up the methane through all the layers. Okay, we got to refresh this to get the color ledger. So this top reading is between 1920 and 2320 parts per billion. So we can see the highest reading here is across northern India, and then it's spread out over this Arabian Sea here, and also over China, and a lot of reds too. We've got red-orange spread out coming across the Pacific. Now let's move on to the sea ice. Here's sea ice and snow cover from Climate Reanalyzer for today. We can see that the extent is coming back a tiny bit. We can see it's almost to the coastline of Alaska and Canada. We can see that the hole has filled in the Beaufort Sea. It's quite thin there, but it has filled in. It's inching back just a little bit, It's struggling, and we're at lowest sea ice extent on record for this time of year, so it means that the refreeze is not happening as well as other years. So that's why I said I'm going to keep watching this. Oops, too far. So here we were last Sunday. Here's what it looked like. There was still a little hole here in the Beaufort Sea. So we can see how it's started to inch back out, and the concentration, where it's more concentrated, it's going to be wider. So there was Sunday. Here's Monday, Tuesday, Wednesday. We can also see the snow coming down on the ground, the white area. So that's Wednesday, Thursday, Friday, Saturday, and here's today. So that's where we're at with that. Just briefly, here is the sea ice thickness for the Antarctic for today. And this is the Navy model. We can see the thickest part, and the mass of it is up here, just near the Weddell Sea, from the Western Peninsula over, and then just up northeast of the Weddell Sea. The thickest is around the coastlines, and most of this will melt during their summer. They're heading into their spring and summer now down there as the northern hemisphere heads into fall and winter. So the thickest is right down here on the southwest edge, and it's up into the 5 meters thick, but this will melt quickly. We can see this kind of open part going into the Ross Sea, where the thickest it's just breaks, and then it's a lot thinner here. I don't know why that is. Then we're going to be specifically watching the Pine Island Glacier and the Thwaites Glacier. That's called the Doomsday Glacier, and a whole bunch of that broke off last year. Here's the 30-day animation. It goes to the 22nd, and the data starts for September the 23rd. So they're just in the beginning of their melt season. So we're not seeing lots of dramatic change yet. We will, though. We will definitely be seeing changes. Now here's sea ice, the sea ice thickness for the Arctic for today on the Navy model. We can see how this correlates to the Climate Reanalyzer. We're seeing the aqua ribbon come back here on the northern coast of Greenland. It's trying to come back. The sea ice is anchoring in. This is what's left of the multi-year ice, the thickest part, and it's anchoring in on these little islands here on the Canadian archipelago. It's thickening up slightly, but there's a crack forming over here, and this piece that had broken off is disintegrating. So I'm going to show that too. Here's the 30-day animation. Now they have not been updating this out to the 7 days from like today, but this is the latest. This is what we've got. It's going out to the 22nd. It's going out to the 22nd, which is 4 days from now. So here's the model where they anticipate it to be, or where the forecast says. I gotta stop it again. Okay, here's the end of the model. Here it is on the 22nd. It's showing reaching the coastline of Canada and Alaska by then, just barely. And this little piece has now been absorbed by and broken up by the sea ice. This is still moving down, and as this is kind of growing, it's still shifting and moving because of the way the ocean currents run there. So let's go back. So this is 7 days back. So there's the 15th. So let's watch this. Here's this little piece. Now watch it. You're going to see it move down. Here's the 16th, 17th, 18th, 19th, 20th, 21st, and 22nd. So hopefully as it starts getting colder up there, it'll stop moving around and just kind of anchor in. But I'm concerned about it. I also found, this is on the Navy website, this is the Beaufort Sea view for sea ice thickness. We can see more in detail this thicker ice. So this is Alaska down here, and here's Canada just to orient. So it's hooking in here. We've got some thicker ice developing here on the coastline. up to about 4 meters thick right here, that little spot. We've got some yellow and green. We've got bright aqua, so this is getting thicker now. But see, this piece had broken off and it's breaking up into pieces and is disintegrating. And now there's a crack here that's going up. You can see this dark line, and where it's dark it's not as thick, and I'm thinking this might break off. And here's another line too, but it is getting thicker here. So here's the 30-day animation on this. So we'll be able to watch this during the winter and see what it's doing, instead of just waiting with bated breath for in the springtime. We can be watching this and see what's transpiring over the winter. Here is the last day. Now this model goes out to the 20th, which is only 2 days from now. So here's let's go back. So here we are today, but I want to go back and show you what's happened, because I've been watching this on a daily basis. Here it was on the 12th. Now see this piece. This had broken off and it's still kind of in one piece. And here's where the crack was forming. See, watch, and it's like 3 different lines here. So let's watch this. Here's the 12th, 13th, 14th, 15th. You can really see it breaking open there. 16th, 17th, 18th, 19th, and 20th. So by the 20th, this is really disintegrating, and it's going down. It's like gonna get caught up in the Beaufort Sea, it looks like. And this little part, this blue, is about 1 meter thick. So I'm watching this very closely. Now we got a little thicker piece up here. So while this is thickening up, it's still shifting. So that's a problem. And we're seeing some thicker ice around the coastlines there too. So that's what I've been studying. Now let's move on. We'll look at Climate Reanalyzer now. Here's the maximum temperature for today. We can see cooler air coming all the way across Greenland and up over the Arctic Basin and then over Siberia. But see, this area is still in the green. This is above freezing. And then cooler air coming down through Canada. Here's 2 meter temperature anomaly. See, set up red still. So it's still, 10 to 20 C higher than normal. And this is one of the reasons that the sea ice is not able to grow back the way it needs to. Greenland is in the red and brown. Then we've got this cold air moving down through Canada and into the US, and then warmer air on the western side. Here's the global view. So the Arctic is now at 4.7 C higher than normal. The northern hemisphere is 1.3 C higher than normal, and the world is at 0.5 C higher than normal. So this is this northern hemisphere reading. That's one of the highest I've seen. So what this does, it changes the jet stream and the weather patterns. Here's precipitation and clouds. We can see it's raining on the west coast of Norway, and raining up here in the North Atlantic next to Iceland, and here in the Baffin Bay. And then we've got snow across the Arctic regions. Here's 10-meter wind speed. We've got some pretty fast winds up here coming across the Arctic region. Here's sea level pressure. We've got a high pressure system here around the North Pole and a low pressure system here on the Siberia coast. Here's the jet stream, and here it's doing this crazy looping and braking. This low is 992 millibars, and this high is 1040. So there's your jet stream that's causing weather chaos. Look at it in the southern hemisphere, it's not any better. We saw sea ice and snow cover. Here's sea surface temperature anomaly. It's updated to Friday the 16th. And we're not seeing pinks anymore, so at least the water temperature is going down slowly. Now it's in the reds and the browns, so it's like 5 to 2 C higher than normal. But that's another reason that the sea ice is having a hard time coming back, because the water around it is so much higher than it should be. And it's warm up underneath. It's melting from underneath too. Here's this red spot in the North Atlantic. This is where we saw that methane popping up. And then the Pacific is all brown here and red along Southern California and Baja. And we've got a blob out here off the coast of California. So worldwide, the sea surface temperature is up 0.4 C higher than normal. The North Atlantic is up 0.9 C. The Northern Hemisphere and North Pacific are up 0.8 C higher than normal. Now let's go over, this is National Snow and Ice Data Center. We'll look at sea ice index. This is the Arctic on the daily. This is as of yesterday. This is concentration, and we can see the blue, it means it's not as concentrated, and the white is more concentrated. So this correlates to what we saw on the Navy site. Here's the daily sea ice extent, and the dotted line was 2012, where we were at the lowest extent ever on recorded record. But this blue line is this year, 2020, and we are below the 2012 line. So we are now at record low sea ice extent for this time of year. So what that means is that it's not refreezing parallel to the way it has in recorded history. So what happened this year, see, we were below 2012 in July. See that? So we were melting faster than before, and then it popped up just above the 2012 line in August, and then it kind of ran parallel September and October, or September, and then see how instead of it following this curve, it's like doing a line out by itself. It's got a mind of its own now. So the refreeze is not going well. For the Antarctic, here's the concentration. And we have record extent for this year. It's record extent. It's the highest they've had in a long, long time. This is blue line. But it will melt. It will melt quickly. Now we'll look at NASA Worldview. I'll refresh to make sure we've got the latest data. I'm going to turn on the blue marble view. Here we have, this is the Arctic sea ice concentration for today, and we're looking for white, meaning it's more concentrated and frozen more solidly, and we've got it. We're seeing some white up here. This is thin ice. This is what's new that's come back. The thickest sea ice is living right through here. We saw that on the Navy website, right through here. And so we're wanting that to turn white instead of seeing red. Red is, it's okay, but you know, we want it to be white. Red is like, well, this red is 87. Like when I put my cursor over that, that's 88% concentrated. But you have to remember how much it melted this year and how the ships could just sailed right up to the Arctic, and there was a lot of space in between the big pieces of sea ice. And so that's why it's not as concentrated. It's still a lot of water in between that has to refreeze. Oh, I didn't mean to do that. I meant to do this. So let's go, hang on. Let's go back. Here we were last Sunday when I did the report. So let's see what's happened this week. Here's the 11th, 12th, 13th, 14th, 15th, 16th, 17th, and 18th. So according to this model, the sea ice has reached the coastline here of Alaska and Canada right there. And it's inching back here. It's still quite a ways from Svalbard and Franz Josef Land. It's inching out here on this east side of Greenland. The Baffin Bay is still pretty clear. We're getting a few little dots of refreeze down here. And the Barents Sea is clear. Kara Sea is clear. We've got Gulf of Ob is clear. We've got some little dots here in these bay areas and along the coastline, just dotted areas where it's starting to come back. Here, here, and here. But it's still really clear. They're still able to run ships all the way through the Bering Strait. See, that's all clear. All clear. Bering Strait up through this Chukchi Sea, up around Severnaya Zemlya, and then coming up and around down to Norway. It's all clear still. So there's that. Now I'd like to go over, this is Sam Carana's latest blog post. He posted this Tuesday, October the 13th, this week. And I already shared this with my Subscribe Star members on Tuesday, but Sam Carana likes to keep adding to blog posts, and you know, I've made a suggestion that whenever Sam updates a blog post, if he'd put updated on such and such date, then we'd be sure to look for the new material, because otherwise you gotta like reread and see what's new. And it's important stuff, but you know, I appreciate the work, but that's just a suggestion. So the title is High Temperatures October 2020. September 2020 was the warmest September in the NASA record that goes back to 1880. In the image, September 2020 temperatures are compared to 1951 to 1980. And so these are the anomalies. The highest area of the anomaly we can see up here in the Arctic, and down here in the Antarctic between 4 and 7 C higher than normal. And then the red zone, so that's the dark red, and then the red zone is 2 to 4 C higher than normal. We can see that takes up the rest of the Arctic, and it covers western United States and western Canada. So we're 2 to 4 C higher than normal already. Parts of South America, a lot of Russia here, a lot in Siberia, and coming down into Africa. And most of Australia, it looks like, is already 2 to 4 C higher than normal. And a lot of the Antarctic is in the red zone, 2 to 4 C. And then the golden color is 1 to 2 C. The yellow gold is 0.5 to 1 C. The light yellow is 0.2 to 0.5 C. And the white is minus 0.2 to 0.2 C. Global warming is accelerating. Similarly, Copernicus reports that September 2020 global surface air temperature was the highest September temperature on record. The image below shows temperatures averaged over the 12-month period from October 2019 to September 2020. Here's 12-month European surface air temperature anomalies. So here we are, right at the top. Keep in mind that anomalies in the NASA image are compared to 1951 to 1980, while in the Copernicus image anomalies are compared to the 1981 to 2010 average. Anomalies are even higher when compared to pre-industrial levels, as discussed further below. The Copernicus image shows that the shape of the global anomaly over the past 12 months is very similar to the peak reached around 2016. This confirms that global warming is accelerating because the peak around 2016 was reached under El Niño conditions, whereas current temperatures are reached under La Niña conditions, and while sunspots are at a low, both of which are suppressing temperatures as discussed in a recent post. What causes this acceleration of the temperature rise? James Hansen and Makiko Sato confirm that global warming is accelerating, and they explore whether this acceleration could be caused by fast feedbacks and short-term natural variability, such as the sunspot solar cycle, which they give an amplitude of some 0.25 W to M2. James Hansen and Makiko Sato conclude that global warming is accelerating due to a less negative atmospheric aerosol forcing. Indeed, sunspots cannot explain this acceleration because we're currently in a sunspot low. And there's that image. El Niño, La Niña cannot explain this acceleration either, because we're currently experiencing La Niña conditions, as illustrated by above NOAA image. Further causes could be explored, as the image below shows more than 90% of global warming currently goes into oceans. The image below shows sea surface temperature anomalies in the northern hemisphere from 1981 to 2001 on October the 16th, 2020. So this is similar to what we see on Climate Reanalyzer. Stratification may cause oceans to take up less heat, and the more heat will remain in the troposphere, the faster the temperature of the troposphere will rise, as discussed in an earlier post. As discussed under feedback number 25 at the feedbacks page, the atmosphere can be expected to carry more water vapor as temperatures rise. Since water vapor is a potent greenhouse gas, more water vapor in the atmosphere will contribute to global warming. More evaporation also brings more heat into the atmosphere, as illustrated by the image on the right, and more heat will also be transferred to the atmosphere as the area of open water increases in the Arctic Ocean. Further acceleration of the temperature rise. Further acceleration of global warming looks set to occur over the next few years as sunspot activity increases and as El Niño conditions will return. In 2019, T.R. Donnie et al. Analyzed a number of studies and forecasts pointing at the maximum in the upcoming solar cycle occurring in the year 2023 or 2024. This analysis, discussed in a recent post, found some variation in intensity between forecasts, adding images including the one on the right, which is based on linear regression and suggests that the solar cycle 25 may be higher than the previous solar cycle 24. Here's that. The need to transition to clean renewable energy. Fossil fuel and control over its supply is behind much of the conflict, violence, and pollution that has infested the world for more than a century. Instead of continuing to use fossil fuel, the world must rapidly transition to using wind turbines, geothermal power, solar power, wave power, and similar waves to generate clean, renewable electricity. The transition will remove much cause for conflict. Unlike fossil fuel, clean, renewable energy is available locally around the world, and its use in one place doesn't exclude use of clean, renewable energy elsewhere. This transition also comes with greater energy security and reliability next to its numerous further benefits, e.g., it will make more land and water available for growing food, and it will generate better and more jobs and investment opportunities, improve our health, and will reduce greenhouse gas emissions. Since it's more economic, the transition to clean, renewable energy will pay for itself as we go. And so on. Yet, while it makes sense from many perspectives and is absolutely necessary, this transition will not immediately lower temperatures for a number of reasons. Maximum warming occurs about 1 decade after a carbon dioxide emission, so the full warming wrath of the carbon dioxide emissions over the past 10 years is still to come. As discussed at the extinction page, even with dramatic cuts in emissions, temperatures will not fall as long as levels of greenhouse gases in the atmosphere remain high. Additionally, sulfate cooling loss will further increase temperatures as the world progresses with the necessary transition to the use of clean renewable electricity. And this is the aerosol masking effect that Guy McPherson talks about. So we're baked in the cake to for temperature rise. It's baked in the cake no matter what happens, and it's going to rise faster as we transition over to renewable energies. And Guy didn't think we'll be here that long to transition. Frankly, I don't either. A rapid, steep temperature rise. But, Sam Carana is an optimist and, wants to think that we can, and at least is giving some solutions if people are so inclined. But the government has to get behind it, and they have to stop fighting, and they have to put away their differences, and it's not going to happen. It's just not going to happen. We're living in an insane world. A rapid, steep temperature rise. The danger is that a rapid and steep temperature rise will be triggered by a combination of elements such as El Niño, sunspots, oceans taking up less heat, and changes to aerosols such as further sulfate cooling loss. The potential for such a rapid, steep temperature rise is also illustrated by the image below, posted in February 2019, and showing a potential total rise of 18 degrees C or 32.4 degrees Fahrenheit from 1750 by the year 2026. And Sam, you're going to have to update this graph soon. This is outdated because we've already reached 2C. So you need to update this. It's almost a year old. Soon it will be a year old. A rapid, steep temperature rise would be felt most strongly in the Arctic, causing albedo loss, emissions, and transfer of heat from ocean to atmosphere that would all hit the Arctic most strongly, thus further speeding up the temperature rise as illustrated by the image below. So this is updated to through the September 2020 data. So this is best case scenario. The blue line shows we hit 3C in sometime in 2026. This pink line shows we hit 3C in 2022. But if we've already hit 2C, well, okay, here's 2020. We went above 2C right up here. Look, it went above 2C way back here in 2016. Anyway. So here's 2021. There's 2C. And here's 2022, and that's about that's 2.4C. And here's in 2022, before even 2023 hits, we're up at 3C by late 2022. That's worst case scenario. So we don't have long. As discussed in an earlier post, a rise of more than 5 degrees C could happen within a decade, possibly possibly by 2026. Humans will likely go extinct with a 3 sea rise, and most life on Earth will disappear with a 5 sea rise. Now, Arctic sea ice. Meanwhile, temperatures in the Arctic have been very high, as illustrated by the image below, showing air temperature in the Arctic up to October 12, 2020 in the red line. So here we are. It's up. This is like the green line is the mean temperature, and here we are way above it in the red line. As the image below shows, Arctic sea ice was at record low extent for the time of year again. This is October 11th, 2020, and record low. And here's this dotted line of 2012, and it's zipping back up, and here we are at 2020, below 2012. The sea ice area was also at a record low for the time of year, as illustrated by the image below, showing the situation up to October 9th, 2020. So this is the area, and again, record low here. This dark line is 2020. And this orangey line was 2012. Arctic sea ice volume has been very low, as illustrated by the image below, showing volume up to September 30th, 2020. And so it's been wavering. It's been lowest for some time, and then it hopped up, but now it's at record low again. Temperatures can be expected to remain high. The image on the right shows a forecast for October 17th that was run on October 11th. Very high temperatures are visible over the Arctic Ocean, while the Arctic as a whole shows an anomaly of 5.5 C. It didn't get that high. It was, I can't remember what it was yesterday, 4.9. But it did not get up to 5.5. The forecasts can not play out. Anyway, it's still really high, as we saw. These high temperatures leave little or no opportunity for sea ice to build up thickness over the next few months, meaning there will be little or no buffer to consume incoming heat as temperatures start to rise again early next year. Without such a buffer, a rapid temperature rise in the Arctic Ocean can be expected to take place, threatening to destabilize methane contained in sediments at the seafloor of the Arctic Ocean. The methane threat, as discussed repeatedly in earlier posts such as this one, and is illustrated by the image below from a recent post, methane levels are rising most strongly at higher altitudes. So here we are. Here's 2020. As discussed in a 2017 post, methane eruptions from the Arctic Ocean can be missed by measuring stations that are located on land and that often take measurements at low altitude, thus missing the methane that rises in plumes from the Arctic Ocean. Since seafloor methane is rising in plumes, it hardly shows up on satellite images at lower altitude either, as the methane is very concentrated inside the area of the plume, while little or no increase in methane levels is taking place outside the plume. Since the plume will cover less than half the area of 1 pixel, such a plume doesn't show up well at low altitudes on satellite images. Over the poles, the troposphere doesn't reach the heights it does over the tropics. At higher altitudes, methane will follow the troposphere, i.e., the methane will rise in altitude while moving closer to the equator. Methane rises from the Arctic Ocean concentrated in plumes, pushing away the aerosols and gases that slow down the rise of methane elsewhere, which enables methane erupting from the Arctic Ocean to rise straight up, fast, and reach the stratosphere. Since little hydroxyl is present in the atmosphere over the Arctic, it is much harder for this methane to be broken down. What further makes the rise of methane at these high altitudes very worrying is that once methane does reach the stratosphere, it can remain there for a long time. The IPCC in 2013 gave methane a lifetime of 12.4 years. The IPCC in 2001 gave stratospheric methane a lifetime of 120 years, adding that less than 7% of methane did reach the stratosphere. Conclusion: the situation is dire and calls for immediate, comprehensive, and effective action as described in the climate plan. And then there are links below to all the data. So thank you, Sam, for this post and for your work and for the wonderful archive of material here. I refer to it all the time, and so we're going to keep an eye out on that. Now, and that's why I do what I do. That's why I track methane every day and report on it every day. I track 2 sources. Now we'll look at some earthquakes and then we'll finish up. Here are the pictures I took this morning. We're showing 241 earthquakes worldwide. Here in the lower 48, there were 140. Here in Southern California, from Los Angeles down into Baja, there were 30. Here in Baja, there was a cluster. This is 7 earthquakes right here, with the largest one being a 3.5. This is near Delta, Baja. In the Searles Valley Ridgecrest area in California, there were 31. In western Nevada, from Tonopah over to Mammoth Lakes, there were 34. There was 1 in the Reno area, a 1.3 near Cold Springs, Nevada. There were 4 in Northern California, with the largest one being this 3.4 near Petrolia, California. This is where I call it the fulcrum point, where the San Andreas fault line comes up and meets the Juan de Fuca plate. There was a 2.1 at Willow Creek, and a 1.9 and a 0.4 Mineral, California, near Lassen, which is a dormant volcano. Here in the Pacific Northwest and Yellowstone area, there were 10. We're seeing activity around north of Seattle, up here near Vancouver, and down here in Stanley, Idaho. The largest one was this 3.5 at Stanley, Idaho. Here in Texas and Oklahoma, there were 5. There was again here in West Texas, a 2.7, and there was a 2.8. It's the largest one in Oklahoma. South America is showing 5 earthquakes. The largest one is this 5.5 off the coast of Ecuador and Peru. And then 4.0, 4.5, 4.3, and 4.8, all down here in Chile and Argentina and Bolivia. 4.3 here. Here, Bolivia. Here was a 5.2 near the South Shetland Islands. This is just next to the western peninsula of the Antarctic. Alaska is showing 53 earthquakes, and there was a 4.3 in the Northwest Territories in Canada. There was also a 4-something in the same area a few days ago, so maybe that's coming back to life. Hawaii is showing 13 today, with the largest one being a 2.9 at Pahala. In the South Pacific and the Fiji Islands and Kermadec Islands, we've got 6, and we've got some deep ones. South of the Fiji Islands, we've got 4.4 that was 508 kilometers deep, 4.3 Fiji, 388 kilometers deep, 4.6 south of the Fiji Islands, 503 kilometers deep, 4.2 south of Fiji Islands, 587 kilometers deep. Then we had a 5.1 at Wallis and Futuna, and a 4.8 in the Kermadec Islands region. So this is a lot of activity and a lot of deep, deep, deep earthquakes, which will cause plate movement around the planet. This is Indonesia and Philippines we're looking at. We're seeing 6 earthquakes here, 4.3 up to 4.8. Japan is showing a 4.4 near Shizunai, Furukawa-cho, Japan. This is next to the northern island. And then we've got 4 in this picture. We've got 2 at Greece, a 4.0 and a 4.4. 4.4 at Shache, China, and a 4.4 in Tajikistan. Those are the earthquake pictures. Let's see if anything else dramatic has happened on the earthquakes. This one, 5.1, Indonesia. I don't know if that was on there or not. I heard reports that people are warning about the Cascadia subduction zone, but here's a 2.4 on Vancouver Island, Canada. You know, you can prepare all you want, but if you get a big one like that, you know, if you're living there, there's not a lot you can do. And I think God has us placed where He wants us. And, you know, if you feel it in your spirit to to go, to move, to leave, then I say do it. But I think we're in the end times, and the Bible has predicted these things. And Jesus says in Matthew chapter 24, where his disciples asked him the signs of his coming return, one of the things he said was earthquakes in divers places. And I know that there will be great cataclysms, and we're going to see that, and it's going to be more and more and more. A lot of people are not going to make it through these cataclysms, and then the people who are left, it's going to be hard for them. And so, I'm just praying. I'm just praying and asking for God's supernatural divine protection and supernatural divine guidance, and that's all we can do. And if you get quiet enough and you ask for God to come into your heart, and if you ask for forgiveness of your sins, you can get that divine connection, and you can hear the still small voice. You'll be able to know what to do. And it's up to each person, and unless you have that personal relationship with Jesus and with God, you're going to be lost. You're not going to have a compass. There will be not a compass for you to follow, and you need your own inner compass rather than looking outside. And I can only show so much, but then you're the one that has to decide what you're going to do. So I'm reading the prophetic books of the Old Testament. We're almost done with them. Tonight we're going to read Zechariah chapter 7. And it came to pass in the 4th year of King Darius that the word of the Lord came unto Zechariah in the 4th day of the 9th month, even in Chislew, when they had sent unto the house of God Sherezer and Regem-melech and their men to pray before the Lord, and to speak unto the priests which were in the house of the Lord of hosts, and to the prophets, saying, Should I weep in the 5th month, separating myself as I have done these so many years? Then came the word of the Lord of hosts unto me, saying, Speak unto all the people of the land, and to the priests, saying, When ye fasted and mourned in the 5th and 7th month, even those 70 years, did ye at all fast unto me, even to me? And when ye did eat, and when ye did drink, did not ye eat for yourselves, and drink for yourselves? Should ye not hear the words which the Lord hath cried by the former prophets, when Jerusalem was inhabited, and in prosperity, and the cities thereof round about her, when men inhabited the south and the plain? And the word of the Lord came unto Zechariah, saying, Thus speaketh the Lord of hosts, saying, Execute true judgment, and shew mercy and compassions every man to his brother, and oppress not the widow, nor the fatherless, the stranger, nor the poor, and let none of you imagine evil against his brother in your heart. But they refused to hearken, and pulled away the shoulder, and stopped their ears, that they should not hear. Yea, they made their hearts as an adamant stone, lest they should hear the law, and the words which the Lord of hosts hath sent in his Spirit by the former prophets. Therefore came a great wrath from the Lord of hosts. Therefore it is come to pass, that as he cried, and they would not hear. So they cried, and I would not hear, saith the Lord of hosts. But I scattered them with a whirlwind among all the nations whom they knew not. Thus the land was desolate after them, that no man passed through nor returned, for they laid the pleasant land desolate. Zechariah chapter 7. So they didn't want to hear, and they didn't want to change their ways, and they didn't want to follow righteousness. I see this. No one wants to repent. I don't see repentance. You know, people should be repenting and asking for forgiveness and asking for God to guide them and show them what He wants them to do. I don't see that happening. But I'm still praying for everyone. I'm praying for the lost especially. Time is very short, and Satan is going to try to deceive as many as possible. So the Holy Spirit will help open your eyes past the deception. So I love you all, and until next time, I'm praying for you. God bless you. Go in peace, and I will talk to you soon. Good night.